Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for rotate array problem. Let's look at the problem description. We are given an integer array. We have to rotate that to the right by k steps, and k will be a non-negative number. So let's look at this example. So we are given an array 1, 2, 3, 4, 5, 6, 7, and we have to shift 3 times. So each time we shift, this number will go here, the rest of them will be shifted. So that's what we are seeing. Finally we see 5, 6, 7, 1, 2, 3, 4. Okay, and let's see how to solve this problem. We can solve this problem by simply shifting all the elements k times, right? So basically we can store the rightmost element in a temporary variable and shift all of them one position right and put this number into the first position. So we can repeat this process k times. So that will lead us to order of n times k solution. So the next approach is reverse array approach. So in this case, we reverse the array a few times. At the end, we will be getting the shifted array. So first time we reverse the whole array, second time we reverse the first k elements, and third time we reverse the last n minus k elements. This will take order of n time complexity. Let's look at the flow chart. For this procedure, the inputs are the nums array, integer k. First we are initializing the count and we update the k. For example, if the k is greater than count, then we have to do modulo k modulo count so that we can shift only the required number. So if we shift the array count times, we end up getting the original array. So if k is greater than count, then if we do modulo, then we can get only the count which is necessary. Next we reverse the entire nums array, and then the elements from 0 to k minus 1 entries will be reversed, and in the after that the elements in k to count minus 1 entries will be reversed. Finally we get the shifted array, and we return the output nums. Let's move on to coding. First I initialize the count variable to the number of elements in the array. I do k modulo count to compute the number of shift that will result in reordering of elements in the array. Now I call the reverse array function to reverse the entire array, passing 0 to count minus 1 as the start and end indexes. Next I call the reverse function to reverse the first k elements of the array. So I am passing 0 to k minus 1 as the start and end indexes. Finally I call the reverse function to reverse last n minus k elements in the array. Next I'm going to write the reverse function. It's a simple one. So in the for loop, until the start and end pointer meets, we keep swapping the elements pointed by the start and end indexes. And increment the start index and decrement the end index. Next I'm going to run this program. Okay, it's accepted. So next I'm going to submit this program. Okay, cool. It's accepted. Let's do the code walkthrough with sample input. Let's use this input for the code walkthrough. So the nums array has 1, 2, 3, 4, 5, 6, 7, and we have to shift 3 times. So initial input array, and so in the rotate function we initialize the count to 7, total number of elements, and then we do k modulo count. So but 3 is less than count, so we still get the 3, and then we do the reverse the entire array 0, index start index 0 and end index is the end of array, and then we after reversing that we will be getting the input, the num array will be like this, and the num array will be like this, and then we do reverse first k elements. So these 3 elements reversed. So earlier it was 7, 6, 5. Now after reversing it's 5, 6, 7 and 4, 3, 2, 1. So now we do third reverse with start index as k and the last index is count minus 1, basically the last n minus k elements in that array. In this case it is 4. So this part of an array we reversed and then we get it 1, 2, 3, 4. So this is a shifted array. So the 5, 6, 7 are shifted to the beginning and the rest of them are shifted right. Let's do the time and space complexity for this solution. Let's take a look at the two cases for doing the time complexity and space complexity. So for this case, nums has 7 elements and we have to shift it 3 times. So we are making 3 reverse function calls, and let's see how many times this loop executes. For this full reverse, this loop executes 3 times, and then first k elements this executes 1 time. So basically these first three entries, so when we reverse this loop runs only 1 time, and for the remaining 4 elements it will run 2 times, so totally 6 times. So next let's take a look at this case. There are 4 elements, we have to shift 2 times, and for the full array reverse the for loop executes 2 times. For 2 elements the for loop executes once, so the remaining 2 elements it executes once, 4. So pretty much equal to the array size, input array size. So the time complexity is order of n. With respect to the space complexity, we do not allocate any additional space, so everything is done in memory, so space complexity is order of 1.
Thanks for watching this video. Have a great day.